Unit 3, Learning Target 5D. I can factor special cases. Again, always look to take out the greatest common factor first. Alright, in example 1, first thing, greatest common factor, 9, 12, 4. Nothing we can take out with our numbers. We've got x squared x and no x's, so we can't take out a greatest common factor. So since our a value isn't 1, we can't just straight factor yet. We either have to guess and check or slide and divide. So if I did guess and check first, or if you choose to do guess and check, we'll do that one first, then we'll also do slide and divide. So 9x squared. Looking at that, I know that 3x and 3x would get me 9x squared. Then 4, I'm seeing 2 and 2. So that's my guess. So I'm going to check by looking at my outers and my inners. 2 times 3x is 6x. 3x times 2 is also 6x. If I put these together, I can get 12x if we've got 6x plus 6x. And that also gives me a positive 4 if they're both positive. So we need both of them to be positive to get back that 12x like we wanted. So our first guess was correct. Option 2, if you'd rather do slide and divide, we've got 9x squared plus 12x plus 4. We slide our 9 over by multiplying 4 times 9 to get x squared plus 12x plus 36. Then we factor, just like normal. We know we've got x and x, and we're trying to figure out what multiplies to get 36 and adds to get 12. So I'm thinking 6 and 6 multiply to get 36 and add to get 12. Want them both to be positive. Next thing we do is divide. And again, you divide by what you slide. So we slid a 9, so we'll have to divide by 9. Simplify is next. So 6 over 9, we can take a 3 out of both of those pieces. So that leaves me with a 2 over 3. 6 over 9, we can take a 3 out of both of those pieces to get 2 over 3. After we simplify, we slide back. So that means whatever is on the bottom goes back out to the front. So we've got 3x plus 2 and 3x plus 2. Alright, so if you're looking at this, you're thinking, well, what makes this special? It's no different than what we did. And that's why I personally don't like to necessarily have this as a separate learning target. Basically, what makes this special is that you ended up with two factors that were the same, 3x plus 2 and 3x plus 2. So I guess the special part is that your final answer would be written like this. It's special because this is what we call a perfect square. So I guess that makes it special. Alright, we'll look at another example. First things first, greatest common factor. I'm seeing that we could take a 3 out of all three of those things. So if we divide each piece by 3, that's what's going to go on the outside. The first piece, you'll have an x squared left. 12x divided by 3 is 4x. 12 divided by 3 is 4. Now, since we took out the greatest common factor, our a value is 1. So the good thing is we don't have to slide and divide or guess and check. We know x squared is from x and x. What multiplies to get us 4 and adds to get us 4. So we know 2 and 2 multiply to get 4, and added together they also get you 4. So we put a plus 2 and a plus 2. Again, this is special because since it's the same two things, we can write x plus 2 squared. That's what makes it special. These things are perfect squares. That's what makes these special. All right, example 3. Looks a little bit different because there's only two terms. That middle term is what we're missing because we don't have just an x thing. So if it helps you to write in the 0, go for it. Since our a value is 1, we know we're going to put x and x. And now we're looking to see what multiplies to get us negative 25 and adds to get us positive 25. So if we guess negative 5 and 5, add those together, we get 0. So that's what we wanted. Plus 5, minus 5. We'll go ahead and do the second example, and then we'll look and see, okay, why is this so special? 8x squared minus 162. I'm seeing both of those could have a 2 taken out of them. So your 2 goes up front. 8 divided by 2 is 4. We didn't take out any x's, so x squared. 162 divided by 2 is 81. And now let's look back at example 3. What made this special? I'm seeing that these two things are something squared. We've got x squared here, and we've got 5 squared here. And it's subtraction. So let's look at this next example and see if we've got the same idea. We've got 4x squared minus 81. Well, 81 is 9 squared. 4x squared. We could say that's 2x squared. So let's see if it works the same way. 4x squared. We could say that's 2x and 2x. 81. We wanted to multiply to get us negative 81, but add to get us 0. So it's going to be the same idea. We're going to have a positive 9 and a negative 9. So what makes these two special is that they're a difference of squares. Difference means that it's subtraction. Squares means it's something squared. So these are actually really simple because as long as they're subtracted and it's something squared, they're going to be the same exact thing except one positive, one negative. So if we look at example 3, we had a positive 5 and negative 5. Other than that, they're the same. Example 4, we had a negative 9, a positive 9. Other than that, they're exactly the same. So difference of squares, same thing, one positive, one negative.